Welcome to Brain Vision.
In this question, a cannon fires a projectile by applying a force of 4.9 times 10 to the 5th newtons on it, and by doing that, it's capable of making its velocity change from 0 to 4 times 10 to the 3rd meters per second. Knowing that the mass of this projectile is equal to 5 kilograms, we have to determine how much time does it take for its velocity to change from 0 to 4 times 10 to the 3rd. We begin by remembering that the acceleration is defined as the variation in velocity divided by the time it takes for that variation to occur. Then, we can solve for delta t here by sending this term to the other side and this term to the other side. And this gives us delta t being equals to delta v divided by the acceleration. And this is the equation we will be using in this question. The variation in the velocity is equal to 4 times 10 to the 3rd. And the only thing we don't know now is the acceleration. For that, we can use Newton's second law, which says that the net force is equal to the mass of the projectile times its acceleration. The net force is equal to 4.9 times 10 to the 5th. The mass is 5 kilograms, and the acceleration we are calculating right now. Then, by sending this term to the other side, we get 4.9 times 10 to the 5th divided by 5 as our acceleration. Then, we can plug in this result in this equation. By doing that, we get delta t is equal to 4 times 10 to the 3rd divided by 4.9 times 10 to the 5th divided by 5. And this is equal to 5 times 4 times 10 to the 3rd divided by 4.9 times 10 to the 5th. And then we get the following. 5 times 4 is equal to 20. And this is divided by 4.9. And here we have 10 to the 3rd minus 5, because we have 10 to the 3rd in the numerator and 10 to the 5th on the denominator. So this results in 20 divided by 4.9 times 10 to the minus 2, which is 2 divided by 4.9 times 10 to minus 1. Finally, this gives a time of approximately 0.4 times 10 to the minus 1, which is equal to 0.04 seconds.